I would now like to start the second session of the day with our chair, Mr. N. Murugesan. Sir, I request if you can come on the dais. We are starting with a presentation of Mr. Brijesh Singh, Associate Professor, Department of Electrical and Electronics Engineering, Faculty in Charge, KIET Center of Excellence for PET and CEI. And the presentation is on design and development of grid-tied off-board intelligent charging station.
This particular session will be talking about the new technologies and foundation technologies. If you see that smart grid, smart grid consists of so many blocks. Start with home automation. Though it is not talked much right now, in developed countries it has come in a big way. So then next we talk about the smart meter. So that is another building block. Then we go from automatic meter reading to advanced metering infrastructure. Then we land up in the control center. The control center, one is a metering related control center, and that need to be integrated with your distribution management systems. So it's called, the various standards are there. We will talk about the numbers, 61968, or if you talk about the transmission systems, we talk about energy management systems. Then when we come down, we talk about feeder automation, to just to have a reliability. Then we go to the substation automation, then group of substation, we call it a distribution automation, then transmission automation, then we go to the generation automation, then we come this side because we have a renewable energy. So there is another layer of renewable energy. You have whether you talk about solar or wind or any form of renewable energy, so that is another layer of things like that. So when you have a renewable energy, then again we need to talk about storage systems. So this is another layer. Then we talk about the storage. Now electric vehicle comes into picture because it addresses climate change, like that. So another layer comes into picture. So friends, the smart grid can be classified consists of various layers. Somebody is working on particular one, you address the things, and a galaxy of standards numbering 250 plus standards are available to address holistically the smart grid, the concepts, the smart grid framework. So we will be talking about only about reliability and how do you optimize the energy value chain. Of course, when you talk about that, climate change is a part of that one. So there are only three things we will be addressing. We call it as a smart grid, we call intelligent grid, or wise grid. So finally, we are addressing only the three systems. There is reliability and addressing the energy value chain, optimize the energy value chain, and again finally addresses this climate change. So friends, see, we have approximately about around 9 papers are there. So we are into this lunch time very strangely. So I request all of you to see that, because people would like to attend some other sessions like that. We will be very strictly, within 5 minutes, whatever time allotted, kindly see that it is adhered to this timing. And already we have some about 15-20 minutes already gone. Kindly I request your cooperation to see that within time we will complete.
Thank you.
Thank you, friends.
Thank you, and very warm good afternoon, everyone. My name is Dr. Brijesh Singh. I am from Kite Group of Institution, Delhi NCR, Ghaziabad. Here I am going to address one of the topic which is very required, I think, because nowadays the country is going towards the e-mobility, and they are evolving so many technologies. They are implementing the so many standards and technologies here, and because when we are talking about the electric mobility, also the grid is a major challenge, and how we can address these problems. So me and along with my one of the student Devashish here, we have gone this idea for design and development of grid type off-board intelligent charging station. Why we have picked this topic? So in a quick manner, just we go with the some basic things. The data which is available in a public domain, I have taken this one. So around 2030, the 94.4% vehicles may be the electric vehicles, and the two type of vehicles are mostly preferred for that, the battery electric vehicles and the plug-in electric vehicles. So that is the growth which is predicted up to the 2030. So on the basis of that, we can say that the growth of electric vehicle in the industry and future of transportation is very important. It will play a very important role in a country growth. Then role of advancement in battery technology and charging infrastructure is also one of the very important concern. So what kind of the need is required? That is first the innovation and investment for the charging technology. Although the people are working with the battery management system, vehicular technology, different kind of vehicles, but the major concern, if we are talking about the smart grid, so the thing is related to your that charging station. So and the second thing is the large scale charging infrastructure, how we can implement the large scale charging infrastructure. So in a quick manner, there are two type of charging systems are there with the vehicles, is the AC charging and the DC charging. AC is the slow charging system, and which is directly connected with the grid. DC charging is the fast charging system, means firstly we take the power from the grid, then convert into the DC and charge our vehicles. So we require an onboard charger in a AC charging system, and DC charging system we didn't require any onboard charging. So I got some information from the public domain, or it is collected from the chat GPT. What kind of the vehicles are present in India, especially the car and e-cars, and what is the battery specification and charging methodology. So you can say there are the different kind of charging voltage level, different kind of charging technologies are there, battery specifications are different, means the variety of battery technologies are available in India with the car. So on the basis of these data, we have found things. If we compare the onboard charger, so there are a comparative study, means what is the onboard charger and offboard charger. So all the green colored things are represented that these are the advantageous part of the offboard chargers. Means if we go with the fast charging scheme, then we get the high transfer of energy. Then second, weight of the vehicle will be less. Third, that is the charging time is very fast, and charging power level is high. So these are the good thing about the off-board charging station. But if you are talking about the some little bit problematic areas, that is the complexity in the BMS design and cost, then charging flexibility is not there, and identification of malfunctioning in a battery cell. So these are the some identified gray areas where we require to work if we go with the off-board charging station. And these are the two things, that is another gray area where we can work. So that is just a comparative study in between on-board and off-board charging station. Why we advocating the off-board charging station? Suppose if we go with the off-board charging, and off-board charging for the different kind of vehicles, so we require a different charging station. Every car station, every transportation system like a EV, e-cars, e-bus, they require the different type of chargers if we go with the charging fast charging station. Likewise, so here the idea is what? Why not a common charging station like a filling station? All the filling station having a petrol, diesel and CNG right now, and means you have a three type of nozzle irrespective of type of vehicles. So if we are going to introduce a smart technology, smart vehicular technology in our country, so why not we go with the such kind of charging station which have a adaptive facility, which can adopt the any kind of vehicle technology, means battery technology, and charge it in a fast manner. So maybe it will provide a strength for the e-mobility mission. So the key things are the common charging station, adaptive chargers, common charging terminals, and all type of vehicle can charge here. So on the basis of this idea, we have implemented or experimented one experiment in our laboratory. That is, I have already covered the relevance why these things are required. Off-board charger is good because it the people having only two things. One, time is a major concern. Second, the thing means if you go with the different type of battery technology, so if you require the means different kind of vehicle having different battery technology, different charging technology, and you require a separate charging station or a on-board charging system in your vehicle. So that's why the people having these two major concerns, and that is, I think this is a major barrier to promote the e-vehicular e-mobility mission here. So on the basis of that, because very less time, so we have I just covered in a little bit manner. That is a key feature of proposed work is design of an intelligent off-board universal charging system with adaptive charger method. So we are using the adaptive control theory here. Then design of a communication strategy, because if you are talking about the common terminal for all kind of vehicles, so definitely your terminal should identify the battery pack, requirement of the battery pack, and then accordingly set the voltage and current level, charging and discharging rate, charging rate for the vehicle. So these kind of facility will be there, and the proposed adaptive charger can detect the various information, whatever the technical information which is required from the battery pack, that will be communicated to the terminal. So on the basis of that, we have a model, a system, mathematical model, and simulated in a MATLAB package. Especially 1 to 5 second delay we have created here for the initial communication purpose. Means whenever a customer plug their vehicle with the charging terminal, then there will be a communication in between charging terminal and your vehicle battery pack. So all the information will be fetched by the charging station, and it can be easily set by the charger by the control strategy. So we have tested for the different kind of battery pack. A small experiment we have conducted only in a simulation area, and the entire project is in pipeline in a hardware part of we are going to implement the hardware part of this one. So this is the just overall control strategy, because very less time, so I am just showing that what kind of work we have do. So grid tie on-board intelligent charging station firstly we have designed, and then a charging station control system we have designed, and then integrate it and simulate it properly on a MATLAB simulation platform, and we got a very good results. This is the algorithm part for the identification of charge controller parameters, and these are the some test result and observation. Whenever we are going to connect any kind of battery pack, so our grid is stable within a very few seconds as per the IEEE standard grid power quality policies. We have checked it. The voltage and current level at the charging station is under the control, and SOC level, if your vehicle is we have means part the total battery pack in a two part, means the battery which having the SOC level is 60% and 80%. So we have tested it and simulated and got the result on those simulation. So as for the key takeaway, means what are the summary of the work. So need of universal off-board charging, it can improve our e-mobility mission and attract more customer to buy or procure the electric vehicles, because it may be solve the problems, and we can create a common charging infrastructure throughout the country. So then adaptive charging methodology will be useful. Then tests are conducted on a following battery pack. So in last, the proposed adaptive chargers provide a optimal charging options, while charging algorithms ensure efficient and effective charging method for maintaining battery health by avoiding the overcharging or overheating. So we have taken a few constraints as a limitation, not a overcharging or overheating problem during the off-board charging scheme for any kind of battery pack. So this is the overall thing. Thank you. And my student Devashi, he is working with me on this particular topic. That's why I am introduce him. And if audience having any query, then
Thank you very much, sir. Actually, we thought of giving you 13 minutes, but you have completed within 9 minutes. So nice. And I have only one question.
Yes, sir.
Actually, there are IEC standards available to say that what are the capacity in the standardized. So there are multiple standard things driving business.
Yes.
Whether it is Toyota or General Motors, they will have their own commercial things. It is set apart. That standards are available. I think maybe because education institutions are not exposed to the standardized way of working. Do you have access to the standards?
Yes, sir. Sir, I would like to actually. I have a very small time. That's why I couldn't show our algorithm part. Actually, our system having a one facility. Any kind of battery pack, firstly it communicates with the charging terminal, and as per the minimum and maximum range, we can set the voltage and current rate as per the requirement of the battery pack and as per the standard. So it's an adaptive charger, not a single charger for a vehicle, DC to DC charger.
I understand. Maybe that you can go to the previous slides if you do not mind. Need of universal off-board chargers.
Yes, sir.
So there are the standards are available. That's what I want to mention, that the standards are available. What is that capacity, all such things. So you differ with that things?
Sir, actually, what I seen from the public domain information or whatever the things are available in the public domain. Suppose if I buy one car, for example, XYZ brand. So I have a two opportunity. Either it will be connect with the slow charging through AC power. I can draw the AC power from the grid. Second, either I have to install a one charging station which provide a DC fast charging solution for me. But the problem is what if I procure a one car of X brand and I need a fast charger. So either I have to install the fast charger, means carry our fast charger for any place, and I always took power from the grid at that high level, or I have only one opportunity, we can go with the slow charging scheme. So if we got a charging kind of setup like a petrol pump, like a filling station, in everywhere there is a charging station which have a adaptive charging. It is under research. That's why I am saying it is just a part of research.
What I am trying to tell you, we understand. Because the standards are very expensive.
Yes, sir.
And normally in an education institution they don't buy that because they are not. That is not good. But the industry, they work on standardized practices.
Yes, sir.
But practically we have to come to the field. So what my small submission is that there are standards available. Kindly have a look at it.
Yes, sir,
so that you can better modulate your research.
Yes, sir. Right, sir.
Thank you very much. Thank you very much.
Now I would like to invite Mr. B. Venkat Raman, sir, if he is here present with us for the presentation. The presentation is on framework and government policy for retrofitting existing petrol diesel vehicle, a case study. Sir belongs to an organization, Bioelectrical and Energy Systems.
Yeah, good afternoon everyone. I am Venkatatnam from Bioelectrical Energy Systems, Hyderabad. See, my today's paper is on the need for a framework and government policy to convert the existing ICE based vehicles into electric vehicles by retrofitting them. So basically the central and state governments have come out with many policies for the e-mobility and for usage of electric vehicles in place of the ICE vehicles. Okay, the main objective is, as we all know, is the reduce the carbon footprint and also to go green approach, aligning to the practice of globally, and it also helped to reduce the foreign exchange dependency on the import bills, and also to reduce contain inflation, etc. And despite all these, with these policies, the number of electric vehicles are going on increasing. Okay, but it will further ramp up in the coming years also. Yeah, this one. So the new electric vehicles that are adding to the existing fleet are creating instead of replacing the existing one, just by adding the new electric vehicles is further increasing the traffic jams and peak hour jams and traffic rules also. And for everyone to come after the policies also, everyone to go and purchase the new electric vehicles, it is very difficult for people, because in India the two-wheelers, the vehicles are being purchased by middle class and lower middle class people. Okay, so with these regional imbalances in income levels of the people, it is very difficult for them to go for a new electric vehicle, because the electric vehicle, the cost of electric vehicle is anything between 1.5 to 2 times the normal cost of an ICE vehicle. So that is one reason why people are not able to afford it. And another reason why we are presenting this paper is that the public policy is there, and it has to be affordable and acceptable to the public also. Yeah. See, the adding up of new electric vehicles only will not be in a position to mitigate the climate change and is not able to improve the public health for which the policies are designed. Okay, government has announced the scrapping policy, but as I said, because of various reasons, the people, the middle class and lower middle class people will not be in a position to go for a new vehicle by scrapping their own existing vehicles. So because of various reasons like high cost of the vehicle and not having enough knowledge about the electric vehicles, and like your say the charging stations, number of charging stations are not yet were installed. So that is the main reason why people will not be in a position to immediately shift to the electric vehicles. Yeah. So with this, the India's commitment to the EV 30 at 30 is initiative, global initiative, will be to target around 30% of the new share of sales to electric vehicles. The number of vehicles that are increasing means two-wheelers may be increasing by 24 mio within 10 years, and the three-wheelers by 2.9 mio, and 5.4 mio of four-wheelers may be added to the existing fleet of our ICE vehicles. So just by adding these vehicles, the carbon footprint cannot be reduced. So we thought the retrofitting is the idea which will address all these issues. So customers will not be forced to purchase a new vehicle. They can have an option of converting their existing vehicles into a new electric vehicle by fitting a electric motor to that. So opening of second issue is the opening up of low cost charging stations along the highways and in the street corners will address most of the issues that are being faced by the presently on the infrastructure front, because we have come out with a new product by power multiplier. So that power multiplier, using that power multiplier without much of investment, we can install number of charging stations, like in the case of your PUC testing kits, which are being installed at various corners of the cities and along the highways. In the same way, the mobile car charging stations can be installed we are using the power multipliers. Okay, this will address the infrastructure front also, and that will allow the people to shift to their shift their existing vehicles to the electric vehicles by retrofitting. So this retrofit idea conceived from the policy and framework for e-mobility, we have some recommendations and suggestions to meet the Indian scenario. That is, one, existing 10-year-old ICE-based vehicles can be retrofitted with hub motor and thereby enabling them to work with electric current too. So this is one good idea where we will not be in a position where we need not to go for scrapping of the existing vehicles, by thereby saving the asset and also converting them and reusing them with electric vehicles, which will serve our purpose of reducing the carbon footprint. And we have conducted a study on two-wheelers, where a 125cc two-wheeler, which is giving a mileage of around 40 kilometers per liter of petrol, and we have fitted it with a 1.8 kilowatt of battery motor, and we have tested with the DC power source of 30 amps and 60 volts battery. So we have done a case study on these two-wheelers, and where we found out that the mileage of a 125cc electric normal ICE vehicle will be around 40 kilometers per liter of petrol, and for the same vehicle which is fitted with a 1.8 kilowatts of motor, electric motor, the mileage is coming to 40 kilometers per 1 unit of charging. So average distance, suppose if the vehicles are covering around 40 kilometers per day and 5 days a week, then 200 kilometers every week they will be running equally, that ICE vehicle and retrofitted vehicle also. The cost of fuel is assumed at 100 rupees, and whereas the cost of the charging will be around 10 rupees per unit. So basing on that, we have arrived at the cost of the maintenance of the electric vehicle and ICE vehicle for 2 years. The 2 years, the cost of running of a ICE based vehicle will be around 52,000 rupees. Mostly is on the fuel front only, and for the same vehicle which is retrofitted with electric motor, the cost will be around 10,400 rupees. Thus, saving within a 2 years, we will be saving a amount of 41,600 rupees. So basically, after we have in 2 years time, we will be saving around 40,000 and odd rupees on by retrofitting an existing ICE vehicle. So now the retrofitting charges for an electric vehicle is coming to around 80,000 rupees for retrofitting an existing ICE vehicle into an electric vehicle.
It is four-wheeler?
Two-wheelers. We have conducted a study on only two-wheelers right now. Okay, and the state and central governments are giving some subsidies, which if extended to the retrofitted vehicles also, will be around 20,000 rupees we will be getting. So out of 80,000 rupees, 20,000 if the subsidies are given, and if a bank loan of 40,000 is arranged to the consumer, so the upfront the consumer has to pay around 20,000 rupees only. If he is paying around 20,000 rupees, his existing ICE vehicle can be converted into an electric vehicle, and thus he will be left with a burden of 40,000, which he can repay it through the monthly savings that are being saved on the fuel front, which is coming to around 42,000, and that comes to a monthly, he will be saving around 1,700 odd rupees. So even for this 40,000 bank loan, if a EMI of say the loan repayment of around 1,350 is kept, within 3 years he will be in a position to repay his loan also, and at the same time he can own the electric vehicle. And subsequent,
What is that government policy? Anything is available?
that is what we are recommending, that we are retrofitting also they need to give the same concessions and they should allow also.
Okay, you can do that.
Yeah.
Maybe that, is possible, then people will come for.
Yeah.
That's good, sir. That's good.
Yeah.
I have a query.
Yeah, please.
Sir, one query.
Yes.
Sir, whenever we are go with that retrofitting of vehicles, means we need some certification from either ARAI and ICAT. So that, as I felt, means it was my experience, it is a very tough task here. If you have retrofitted a vehicle and if you want to take a certification from the ICAT, so it is again a costly procedure. So that cost is also included in your retrofitted vehicle. So if you are talking about the total entire cost of the EV, no doubt running cost is less. But if you are adding all the cost, certification as well as the raw material, so it again the similar to the same.
Yeah, Mr. Murthy.
When you standardize, you don't need to do each and every vehicle. You do with the standardized kit, automatically the certificate is extends to all the vehicles. I don't think you can.
For every vehicle they don't do.
They don't.
They do only for 3 or 4, then they give the type of flow for your company to do that work. So if at all you think really high cost, just tell me what is the high cost.
No, actually, we have a one Maruti 800 car. In our institution, we have retrofitted it, and we have go with that ICAT certification. Whether we can drive that car on the road. So for RTO permission, firstly we require to take a certification for ICAT.
Right, but no, ICAT is given for the company to do the retrofitting.
Yes.
Not for every vehicle you don't go.
Yeah.
No, yes.
In fact, first 120 vehicles, you don't even require that type of approval.
But it cannot be, sir, suppose I have a vehicle and I have retrofitted
is,
it, I can't drive
No,
it.
individually you may be doing it, but commercially,
Yes.
suppose if you are commercially doing a retrofitting for all vehicles, your company requires that approval, and usually the
Murthy.
manufacturers will manufacture approval.
Hey, in other words, basically, all the expenses for a
Yes.
new product launch, one-time expenditures are non-recurring expenses. So this can be considered NRE terms. So whenever you want to. Yeah, that's all. So basically, the operation cost, the product launching cost, you can divide into various certification costs, one time, they're all one time. Once you incur them, over a period of time, you can, amortize them to the population. Depends on how many you are going to roll out monthly or yearly basis. So eventually, you are going to come out with a steady state pricing. That is the funda. It's not that each and every vehicle has to roll out.
It means either in a structured way, as a company, either I have to procure all the old vehicles and convert into the retrofitted,
Yes.
or I call for a proposal from the customer, कि I am going to convert your car or your vehicle in a retrofitted manner, and I will be responsible for clarification from ICAT. Such kind of things are required. Just
Basically, what is expected out of this forum is that the recommendations what we wanted to have we wanted to request the government is basically to come out with a type testing approval process for retrofitting also,
Maybe.
so that it will create a framework for the people to play around, and then accordingly we can work out what are the various types of tests to be done one time, and then identify the cost and distribute the cost across the population of vehicles to come out with the pricing formula.
Too good, sir.
Yes.
Is there any comparable thing available anywhere in the world? No, you can take, what I'm
Yes,
maybe
and-
a new concept.
Yeah.
It is an innovative concept. If it is available anywhere in the country, in the standardized practices, then that you can bring it, then it is easier to push the government in that direction.
Yes, possibly we need to explore further in that and then, come out differently with some kind of recommendations.
We can explore it, sir. That is easier.
Yeah. Maybe we can have a sitting with you offline.
No problem. That is easier.
Thank you.
Thank you very
Sir,
much.
thank you,
sir.
sir.
It is a good concept. Wonderful. There should be an option.
So moving ahead with our next presenter, Ms. Suvetha Poyamni Sundaraja. Ma'am is Assistant Professor, M. Kumaraswamy College of Engineering, and the presentation is on solar powered smart switching multi-level inverter for smart grids.
So very good afternoon to one and all present here. I am Dr. Shweta Poyamani Sundarraj from M. Kumaraswamy College of Engineering, Tamil Nadu, and along with my teammates Mr. Sanjay and P. Shaktivel, they are pursuing the undergraduation at the same institution. Today we are here to present our topic on solar power smart switching multi-level inverter for smart grid. Before I start my presentation, I would like to give a basic introduction on why I have chosen this topic. So we all know that the rapid depletion of fossil fuels has led to the development of renewable energy systems, and this has motivated me to work in this field of smart grid as well as microgrid. And according to the standards of IEEE 2030, we all know that it provides a possible solutions and requirements for developing a smart grid system. So with this base idea, we have developed a high step-up gain DC to DC converter along with a multi-level inverter in order to integrate the renewable energy sources with the smart grid systems. So this is the basic functional block diagram of our research work, and here we have taken among the renewable energy sources, we have considered solar here. And we all know that the voltage level of solar panel is of a single solar cell is very low. So in order to boost that voltage, we are just incorporating a DC to DC converter, and that voltage can be connected to the grid side with the help of a multi-level inverter. So the respective control algorithms have also been incorporated, and it is shown here. So let me just directly move on to the DC to DC converter part. So this is the developed prototype of DC to DC converter. So here we have taken a switched capacitor cell DC to DC boost converter. So the first diagram shows the actual configuration of the proposed work, and the next two diagrams shows the modes of operation of this proposed work. So it actually operates in two modes since we are having single switch. So the modes of operation is classified based on the turn on and turn off of the switches of the switch. So when the switch is turned on, as it is shown in figure 2, so it is clear that whenever it is turned on, the whole amount of source voltage will be supplied to the inductor, and here the capacitors C1 and C2 will be discharged in the initial stage, and it will transfer its voltage into the output capacitor as well as into the load. And in case of switch in off condition in mode 2, the whole amount of voltage which is stored in capacitor C0, which is the output capacitor, has been supplied to the load, and the energy stored in the inductor will be fed back to capacitor C1 as well as C2. So why we have chosen a switched capacitor cell, and why particularly this prototype? Because when compared to number of high gain DC to DC converters, here we have incorporated a DC to DC converter with a single switch, so that the switching losses of the converter will be minimized, as well as here we have integrated this topology with a switched capacitor cell, so it is easy to boost the voltage from the input side to a higher level at the output end. Here we have taken the sample voltage of 250 volts. The solar panel rating is around 250 watts, and the voltage level is 37.5 volts. So that voltage will be boosted to 250 with the help of this converter, and that 250 volt DC will be converted into AC volt with the help of multi-level inverter. So next I will show you the configuration of the developed multi-level inverter topology. So here we have developed a 11-level multi-level inverter. So the multi-level inverter comprises of a normal H bridge along with a combination of semiconductor switches with diode. Whenever we turn on this complementary switches S1 and S3 along with the sequence of switches, for example, for generating a voltage level of VDC, the first level of voltage, I'm just going to turn on switches S1 and S3. Along with that, the switch S5 will be turned on. So in that case, the first level of the voltage will be generated, and further when we increase the switches randomly, when we turn on the switches in sequences, the next level of voltages such as 2 VDC, 3 VDC, until when all the 5 switches are turned on, the last level of voltage, which is the 5th level of the voltage, will be generated. So when considering both the positive as well as negative cycle, altogether it will form 11 levels at the output end. So the 250 volt input voltage, DC input voltage will be converted into AC voltage in case of 11 levels. So why I am going especially for multi-level inverter is that in order to reduce the THD, because THD plays a major role in case of inverters. So here whenever I am increasing the levels of the multi-level inverter, the THD values get reduced. So over to my team, they will present the results and discussions of this work.
Yeah, I will explain this slide.
Yes, a bit faster. Come to
I
the
will
conclusion.
explain this slide. The switching patterns and waveforms are shown in the slides. As she explained, the switches are turned on in the sequence and expected waveforms in the generator. The output voltage current waveforms are shown in the slides.
As expected, the voltage is around 250 volt and current is around 2.5 amps. The THD is an important parameter in case of inverter design. Here got the THD level of 14% in open loop and 9% of closed loop. The THD analysis is made for switching frequencies and tabulated. We got around 8% for a switching frequency of 2 kHz. Next over to Sweta.
So based on these results, I would like to conclude that the voltage gain of the proposed DC to DC converter is around 6.7 times for duty ratio of 0.4 itself, and the input and output current ripple as well as the voltage ripple is also reduced. Even with if we used a single switch converter with a less amount of passive components. And here we have incorporated a hybrid switching frequency for multi-level inverter for H bridge as well as a different frequency for H bridge and the other semiconducting switches. So this improves the voltage profile of the inverter, and as he said, the THD level is around 8.5 for a switching frequency of 2 kHz. And this has been tested without a filter. So if we incorporate any filter circuit, even we can reduce the THD levels. So we hope that this will be a good solution for those who are working in renewable energies as well as multi-level inverter segments, and we can even work on the reliability and lifetime of power semiconducting switches, and this can also be developed into further level with this base idea. Thank you all for giving this wonderful opportunity to us. Thank you, sir.
One question then, what is that being implemented in normal converter?
Actually, sir, for incorporation of renewable energies into grid, we are just going for this DC to DC converter because the voltage level of solar panel will be very less. So if we add more number of solar panels, it will increase the capital cost of the system. So instead of going for numerous number of solar panels, we are just giving a converter which will boost the level of the voltage. And
What my question is that, as no one has implemented this one, or what is that conventionally?
no, sir. Compared to conventional boost converters, this converter is actually operating with a duty ratio of 0.4 itself. When we consider a conventional boost converter, the extreme amount of voltage can be obtained around 80% of duty cycle, 75% minimum for getting a high voltage gain. But here we are getting around 6.75 times the voltage, because the initial level input voltage is around 37.5 and we are getting a voltage of 250. So the voltage has been boosted to 6.75 times with a minimum duty ratio. So and the topology is also a combination of a switched capacitor cell along with a conventional boost converter topology. So that it is a novel kind of topology in both the cases. We have modified the multi-level inverter also, because in case of cascaded multi-level inverter or any other direct lamp inverter, the number of switches as well as the devices incorporated will be more. Here we have maximum we have reduced the number of semiconducting switches in order to reduce the conduction losses as well as the switching losses of the system.
Okay. Now what I am trying to tell you is that it is a novel concept. No one has done it so far.
Actually, it is in progress, but we have just reconfigured it, and we are just trying to prove that compared to the existing topologies, we are getting a better results, and this can even be further developed, and the results can be fine-tuned based on the practical considerations.
Sir, one. Really wonderful presentation.
Thank you so much.
Confidence with which you are speaking make us to believe that it will definitely will work. But however, we have few questions.
Excuse me. So you said about the voltage boosting, right?
Yes, sir.
But what about the power? If I have a 100 watts, 12 volt solar panel, now say for example that is coming maybe 12 volts instead of 12 volts, maybe 6 volts, but
Sometimes
still that is
yes, sir.
but still that is a 100 watts
Okay, sir.
power. When you are boosting it, what about the power? Is that solar panel current rating is the reducing in your output?
Actually, here
Because
we have
the power is same, right?
Yes, sir. Actually, for that, in order to extract the maximum amount of power, we are incorporating MPPT algorithms, neural
MPPT,
network-based MPPT
yeah.
algorithms, to extract the maximum amount of power. As well as in case of converter side, here we are having a high voltage, low current segment. So even the voltage is 250 volt. According to the power range, the current will be very low. So here we have considered 250 watts, sir. So when we check at the output end, the current will be minimum, the voltage will be maximum.
Yeah, so coming to the MPPT, so the directional part, you are not losing any power because the sun is moving from here to there,
Yes,
your
sir.
panel is moving, that's fine, I agree. But the power, the 100 watts, my solar, I'll bring one solar power, that is 100 watts.
Yes, sir.
Okay, and now we are doing the voltage boosting. Say instead of 12 volts, we make it 24 volt. What happens to the overall wattage? The wattage still remains same, means I'm using at the output finally 100 watts, because finally your bill comes on
Because
the watts.
input and output power should be matched.
Matched. No, I'm not saying it should be matched. If you are doing something great and then some power multiplier is there, we appreciate it. So is that happening? I'm asking.
Okay, so actually,
So because suppose my solar power is 100 watts.
okay, sir.
Your bill also will come for watts per hour. So by implementing your circuit, my current bill is reducing because you're boosting the voltage, but the current is coming down. Finally, the wattage is same, my bill is same.
Okay, sir.
I think their main concept is that the total THD will come down.
Come down, yes, sir.
That's all I think. By boosting the voltage is what they are trying.
So maybe the quality of that thing will increase. Yeah.
It is a
Actually, in
concept.
order to, it's a concept, it's a theoretical level concept, sir. When we go for a practical implementation, actually so far we have analyzed the efficiency also. The efficiency of both the inverter and converter. The major contribution is on the power converter side. So, we all know that the inverters, the major problem with inverter is THD. So here we have concentrated to extract the same amount of voltage, and we need to feed it to the grid, and the THD level should be minimized. So that's our major contribution.
And I have another question.
Okay.
The thing is that, so at the DC-DC converter side, you are saying your unique proposal is that you are making use of single switch.
Yeah.
So in case of making use of single switch, the stress over the switch will be high and the lifetime of it also will be less.
Yes.
So for that, what is your solution?
Actually, we are just working on that. As you said, the stretch of the switch will be high, and we are just working on that. The research is going on. Just implement it.
I think it is a wonderful presentation. This is the forum actually which will give opportunity for people like us to come and
From
discuss.
academic institutions.
And so that eventually the country will get benefited when the good products comes out of these discussions. But the whole purpose of this meets and what we conduct, I think we need to extend the views further. We should not stop here itself, and let us discuss further. And then you have some brilliant ideas that our teams also. Maybe similarly, some other people also having. We need to exchange and bring them a complete cohesive knowledge. We have to make use of it and then come out with an excellent solution, and that can set international standards.
Sure, sir. Sure, sir.
Yeah.
We'll work together.
Good.
Sure, sir.
Just one question.
Yeah.
Presently, what is the TSD being experienced with the present setup?
Actually, it should
We have
be.
the figures, like, are we really facing what is it beyond 3%? What is the
Power quality issue is a major problem even now, sir. Many research works are going on that. The actual level should be within 5%. Even we use a filter, but it should be within less than 5%.
So our regulation is 5%?
Yeah, according to ISUW 519 standard.
I mean to say, Indian, as per the Electricity Act, as per Indian Standard Act, what is the percentage of TSD given?
Actually, these kind of power quality issues will be come under IEEE 519 standards.
Maybe
In that standard,
maybe Gundu sir can elicit some idea on this. He is working on that for quality and other things.
in that
What
side,
is that standard says about it, sir? Indian standard says about.
Till 2018, we have been following the IEEE 519.
He is Mr. Gundu. I know he is working for International Copper Association. Huh? In our session. Next. No problem. It's just a clarification.
No, sir, that I am just informing.
Right.
And today we have our Indian standard, which is IS 17036. In IS 0736, you will have distribution system supply voltage qualities. So PhD portion, the PhDI, if you are asking, we still follow the IEEE 519, but very soon you will have a standard for that also.
Yes, so the next presenter is Mr. Pierre Jacques from iElectrics project, and he's the project director from ENIDIS, and he'll be presenting the results and lessons learned from the Indian demonstration of this project. So
thank you. So good afternoon, ladies and gentlemen. So I will present you the...
You can talk about the project background.
Yeah, of course. Of course, I will explain the situation. But the main topic will be the presentation of the main results and lessons that we learned in this Indian demonstration. So I'm working in ENIDIS. ENIDIS is the main distribution system operator in France. So just some words about the global project, because this Indian demonstration was part of a larger project called iElectrics, a project co-funded by the European Union. It's quite a big budget because we have 11 million of euros. We started in May 2019 and we just finished the project some days ago at the end of February. To work for this project, we have built a consortium with 15 European partners from 8 different countries and 1 Indian partner, which was Tata Power Daily Distribution Limited. So we have implemented several demonstrations. There were 5 demonstrations in total, 1 in Germany, 1 in Austria, 2 in Hungary, and 1 in India. So I will focus on the Indian demonstrations that we call Shakti. So this demonstration has been installed in the premises of high school called Saint Xavier, and in this Saint Xavier school there is a substation, a secondary substation, feeding through 3 low voltage feeders. The school, it's quite a large school with more than 4,000 students and 34, we can say, connecting points, consumers and customers. So here you can see the picture of the final setup. So we use the PV panels installed in the premises. There were 200 kV peak of PV panels installed in the roof of the different buildings. And we have completely renovated the secondary substation. So we have installed a transformer with on-load tap changer. We have installed also a battery energy storage system of 200 kilowatts. And what we call an energy control center with completely new circuit breakers, protection relays, and also a SCADA system for LV grid, and an energy management system working on the cloud. And we have also specific tools, software tools, which represent the LV network digital twin. So I will explain a little bit more what we have done with all this equipment and software. So we'll start with the first results, which is a local monitoring of this equipment, this microgrid. So here you can see the picture of the main picture of this SCADA. So this is accessible also from the control room of Tata Power, so remote access. But here we can see the main transformer feeding the 3 feeders. We can see also the battery, the state of charge of the battery, and if there is some outage on the medium voltage, because this microgrid has a capability to island, to work in an islanding mode. So you can monitor the different parameters, I mean voltage, amps, and also power and frequency. So this was working quite well. And here you can see the results for the monitoring through this LV grid observability system. So it's accessible through a web app. ODT is the name of this company which has developed this system. So with that, you can see the voltage excursions, the imbalance currents, many things. So it's quite an interesting system, and it's taking the data from the smart meters, and after that you can do quite many things with this software. So here we reach this islanding facility. So this was not so easy to put in operation and to test, but we managed to do this. And here you can see an example where the main circuit breaker was open. It was an outage on the medium voltage, and the battery was feeding the feeders. And here you can see on the draft, on the graph, the situation. So you can see a drop of voltage. The blue line or dark lines correspond to the voltage, so you can see the outage. And then after you can see a steady level of voltage. It was a test during 30 minutes for this one. And you can see also the frequency also. I think it's shown here. So during this islanding, we can see that the voltage and the frequency was steady and it was working quite well. So this was the most, we can say, difficult things to be tested. We have also tried frequency regulation test with the battery. So in the dark, you have the power, the dark curve, and you have also the main frequency in green. So when the frequency drops, the battery injects power, and the opposite, when the battery is too high, the battery is loading. So it was just a test because the battery is a little bit too small to have a real large effect. But in any case, it was working quite well. And we have another interesting test also. It was the automatic voltage regulation. So this is algorithm working in the RTU, and this is regulating the voltage. On this grid, there was a quite significant, we can say, voltage excursion. And with this facility, we can manage quite well to regulate this low voltage. So this was also something quite interesting. So now I will reach this what we have learned about this project. So it was quite a long project, and it was not so easy because we design and manufacture all this equipment and software in Europe, and we bring all this equipment in India. And it was during the COVID crisis, so we faced many problems to bring this equipment in India. In India also there is a quite protection barriers custom-wise, so we pay quite a lot to import this equipment also, just for your information.
A lot of companies are operating this.
Yeah. So it is why one of the conclusions is, okay, we can design equipment, but it's better to manufacture in India for sure, because otherwise it will be too costly. We face also some difficulty due to the climate condition in Delhi. With the high temperature, we face some problem with the HVAC system. So we have to replace some part of the equipment and bring back also from Europe. So this was not so easy. And we have to change also, one difficulty to put a microgrid in operation in place due to the size of the battery. I mean the short circuit currents are too small. So we have to change this, and this is tricky things to be done. So we have to change the protection relays also, and to adapt to the real condition of the substation. So also this equipment has been designed in Europe. It's quite difficult for Indian also to maintain. So this also it's a little bit tricky. But nevertheless, we have worked in a narrow collaboration manner with our partners, Tata Power Delhi, and we have every week meetings during almost 4 years. So it was quite a tough experience, but we managed to deliver the results, and so we can say it was a successful project. So thank you for your attention.
And you work with a good partner in India.
Yeah, no.
That's the better part of it. Any question, friends? Okay.
So Pierre, that was a nice presentation, and nice to know your good works in Delhi. So Pierre, the first question being, how was the outage reporting being done? Like, did you the feeders, did they have PTs, or like how was the how did you manage the outage reporting?
The outage. So when we test, of course, we simulate. We simulated. It means we have open a relay, but it was not a real outage from the NV side. But after, we had some real outages, and it works.
So did the meters itself were capable to report the outages, or you had to depend on the relays?
No, outages was automatic detection when the voltage drop below a certain level, or when the main circuit breaker open.
That happened in the relays or in the meters?
No, not in the meters. It is inside what we call the ECC. Yeah, it's the SCADA. It's the SCADA. There is what we call a power management system, managing this islanding mode, and after it's automatic when the main grid come back. It's automatically coming back to the main grid supply.
But in India, we face these particular issues. We may not have the IDs in the substation level in the remote areas and all that. Some major cities may have it. So how do we go about with the meters? How do we report the outages through meters?
This we haven't studied. This we use this new smart meter installed by Tata Power. But it's just to collect information from the clients, that's it. We didn't use at all the meter for the islanding. Of course, we can see that it's recording the load, but that's it.
And my second question is, what was the islanding exercise that you did? What was the need of it?
It was to improve the resilience of the network. It means when there is outages, but of course it's quite costly because you can see this solution is not low cost.
Battery system, does that not make it more costly?
Yeah, it is why. I said it's costly because we have to install this battery. But normally this battery can be used also for other usage. And after this, because this project is over, Tata will continue to use this platform, to experiment other solutions.
So can it happen this way that if we have, like in Delhi, we have this battery swapping stations. So can they be replaced with that? Can these the batteries that you needed there, can these batteries be used in there in case of exigencies? Like islanding may be needed during some kind of natural calamities or something like that.
Yes.
Can these be used in that way?
Yes, but the problem is it's quite complicated to move. This is the issue. But normally we can have some mobile storage system.
Yeah, means to trade off with the economics of
Yeah, in Enedis, for example, we use what we call mobile battery to replace genset, for example. We study this. But this one is quite big, it's 200 kilowatts. So thank you for your question.
Yeah, thank you very much.
So, good afternoon, ladies and gentlemen, friends and colleagues. The topic for presentation is leveraging data in power distribution. Now, talking about Indian power distribution, there are basically two business verticals, content and carriage. While carriage mostly relates to setting up of infrastructure, owning the same, maintaining the same, and in return getting back a regulated return from the regulator. The other part of the equation is content or supply, which involves purchase and sale of the item under question, in this case electricity. So like in any sale purchase business, it becomes very important to measure and account for the item of sale. While on the purchase side, it is getting properly accounted because it is bulk purchase. On the sale side, however, because this is being sold to end consumers, which has disparate levels, so it becomes very difficult to actually, the accuracy of measurement of these sales is very difficult to judge, and many a times it is the theft which is happening at all the levels, including urban, rural, and mostly in collusion with the DISCOM employees. So all these issues can normally be addressed through end-to-end metering of various nodes. But the current status of the same, if we see, 11 kV feeder metering is around 99%, but less than 70% of the same is registered on NPP. Almost 33% DTs are metered. However, if we see the automated data of these meters, that is very less. The equation becomes even more complex because the consumer indexing is either dated or not at all available, so rendering this whole exercise ineffective. So while India might have taken a long time, maybe 20-25 years, to shift from electromechanical meters to electronic meters, now the plan is to go for smart metering in next 4 or 5 years. So a single smart meter is expected to communicate 96 metering data profiles on a daily basis, along with many other data, which along with the system meters would provide near-time end-to-end snapshot of the system. This data can address a number of issues as discussed earlier. In addition, can provide a number of variety of insights. So how is this important in the today's context? Number of state governments have actually committed to take over progressively the losses of the DISCOMs on a yearly basis. Also under RDSS, while it is expected that the state governments would have to take over to provide the tariff subsidy as well as government department dues on a regular basis, meeting all their commitments of the current dues as well as the liquidation of earlier outstanding dues. So how is that important? Let's talk about some of the headline numbers. The state gross fiscal deficit during 2021 stood at 8.3 lakh crore, and DISCOM's cash losses during that year were 14% of that number. Now, tariff subsidy implication to state government during that year was 16% of the fiscal deficit, and this is normally deferred by the state governments because they don't want to pay to DISCOMs. And add to it the liquidation requirement of outstanding earlier government department dues and subsidy dues. This figure of additional hit, this would result into additional hit of almost 35% of the balance sheet losses that the state government would need to bear going forward. Now, how is it relevant? So, how is this relevant from the current? What is the relevance of it today? Because earlier Government of India schemes that Ministry of Power had launched, every scheme focused on the same thing, either network extension or improvement in operational efficiency. However, this time in RDSS, the adequate thrust has been laid on the area to address the issues that lie outside the DISCOM. Like I showed earlier, all the commitments that the state governments are expected to now adhere to will push the state governments to demand profitability from the discoms, because tariff subsidy is one area which no state government is going to touch in the current political environment. So for the areas that are under discom's control, considering the context of privatization, delicensing, parallel licensing, it would serve them to work really hard on improving the service quality of the consumers. And energy transition, it has to be done on the shoulders of the discoms only, and same would involve load forecasting on a hourly basis during the day, for months of the year, for short term, long term. So this is how they will need to plan going forward. And RE integration is an issue which will compound the network planning aspect, which discoms would have been handling as of now. And all this would require availability of quality data. Now, talking about the current situation of the availability of data in the discoms, none of their data is reliable except for maybe annual accounts, because they are getting audited through a third party, so somebody else is having a good look at that. And though discoms have tried to correct it, but haphazard adoption or underutilization of available IT systems has meant that same could not be resolved. Talking about assets of the current discom digital operations, still the MIS at the headquarter level of discoms are getting compiled on a manual basis, on the basis of the Excel sheets received from various divisions, subdivisions, and that too reported in different formats by the subdivisions. So this is just plain garbage, if nothing else. And they have tried to address this problem through an IT systems also, but the same could not be done properly because there is no separate IT cadre or primacy attached to the IT officers, and accordingly it loses the focus. And digitalization is largely vendor driven rather than based on contextual requirement of the discoms, and being implemented through third parties only. In further going forward, inadequate capacity apart, the disparate IT planning and reliance of multiple parallel operations even after adoption of newer systems limits the end utility of these applications. Further, then also discoms resort generally to customization of world-class products, rendering them unusable and sometimes even unstable. But we need to understand this from the planning aspect also, because digitalization is a journey which is not very old for the discoms. It started with part A of RAP DRP, when 100% of the implementation cost was being borne by the GOI, while most of the implementations would have failed to generate due value, but these implementation provided good exposure to and IT maturity to the discoms, and also to the system integrators of working with discoms. Now with that experience under under RDSS, discoms are expected to bring 40% counterpart funds, because when the discoms don't have the skin in their investment, then it tends to lose focus, and the implementation focus now is on SaaS model and cloud, because otherwise the IT implementation would mean that all funds are going to buying more and more servers, more and more IT applications. Now wherever it can be, it is feasible to do this model is being adopted. Now availability of quality data can be a useful business driver for the discoms, but it has some prerequisites. Raw data from sensors and field documents should be available, and without human intervention, and any adjustments that require data cleaning, sanitization, and analytical adjustments for deriving other values, related values, for ensuring data completeness, just like in case of MDM, has to be made part of the system itself. And rather than going bang on for newer analytical softwares, it will serve discoms better to adopt standardized softwares for now and go on improving the same as they go along. Further, the system should be itself able to generate reports and dashboards so that an integrated view is available to the management rather than going in for PPT mode. Now, depending upon the type, availability of data, comparable data sets that are available, and specific objectives of the discoms can have different approaches to the analytics. The first of which could be simply descriptive analysis, describing what is the situation, what is the current situation. Like, let's say the category-wise DISCOM feels that the industrial sales are going down. Then the good approach could be having a relook at the cross-subsidy framework of the DISCOM in the DISCOM area. Or maybe Honorable Minister was taking a meeting in which it was shown that a few feeders showed negative losses. Later it was found out that negative losses is on account of some of the prosumers on that feeder. So I mean, these sort of anomalies could normally be avoided with better data availability, and predictive or forecasting would involve, like in case of Indore DISCOM, they claim to have shifted a lot of lots of consumers from domestic category to commercial category, because it was noticed that those consumers were consuming electricity only during the daytime. Talking about prescriptive of what should we do, like in current framework of KWH consumption, KWH charges, it would serve DISCOM well if it could identify the areas or nodes where directive compensation could help. Same could help in auto targeting of theft pockets, in diagnostic analysis, to finding out what the areas of problem. It could be, identifying why a network assets in particular area of certain make of certain model are getting failed. So such sort of issues can be. But all this would involve for DISCOMs to have strategic digital plan, which would start with actually functional planning, with involving setting up of a separate IT cadre with defined hierarchy to the top. Now having separated the IT cadre, the responsibility of IT office hardware, peripherals, networks has to be placed under the office administration rather than the IT department. Then another thing which we think can provide quite a lot of value to the DISCOMs is if IT and O&M department can have cross-functional posting, so that they can understand the operations functioning of each other better, and what one can do, what are the shortcomings, requirements, so that they are able to develop business-ready applications. Then comes IT planning. So current approach that the DISCOMs have is they see a new problem as a new problem as a separate problem rather than a systemic improvement thing. So they need to have a GST module. So they'll think of a new GST module rather than thinking how the existing system has to be improved. They'll think of a GST module as a separate module. So till the time you don't have a comprehensive visualization of the entire system, these will just become parallel applications. So another thing is reliance on newly adopted IT applications and not keep continuing with the existing IT applications, because after some time you have to phase out the old applications so that the newer applications get requisite maturity, and go for hybrid system planning through SaaS implementation, cloud adoption, wherever the market is mature enough to offer these sort of solutions. And foremost, the product application of best-in-class product or application should also involve change in business process or the business process re-engineering. Otherwise, the major benefit these products offer is not the product themselves, but the business processes changes that they offer. So this is what we are trying to at REC as Ministry of Power, trying to push to DISCOMs, and hopefully it will be of value to the DISCOMs. Thank you. I'm open to questions.
See, many may not know that history about RDSS scheme. The evolution of the initiative started by Ministry of Power way back in 2002, with which I was associated. APDRP, then RAPDRP, then various. It's an intervention from the Government of India in the state financial aspect as well as system aspect of it, because it is a concurrent subject. So central government cannot directly, but at the same time the energy is a paramount for country. Energy security is topmost one, and electrical infrastructure is considered as a critical infrastructure. So that is the reason the government of India is intervening in various forms, indirectly coming to improve the the system about it. So it was a huge intervention, and of course the smart metering initiative what we are seeing now, and the city automation project which has already matured to the highest level, and developing the infrastructure, manufacturing, arts, etc. It is almost 20 years work now we are seeing now. And the REC and the PFC, the Ministry of Power, they are all driving this work for relentlessly for almost 20 years. What we are seeing is that amount of work has gone inside. Thank you very much.
Thank you, sir.
Thank you.
So, moving on for our next presentation, it is on communication solutions for smart grids and smart cities. And to present this, we have Mr. Amit Sharma, Director, EY.
So, just a quick intro. I'm Amit Sharma, one of the co-author of this technical paper selected by ISDF. And I must appreciate the ISDF's initiative of reaching out to industry people and spearheading the knowledge session. Coming back to our paper, just a quick context here. Data is the new oil. Since the day Mukesh Ambani made this statement in Reliance Group's AGM, everyone is quite gung-ho about the data part and talking about data and its importance in the sector. What I say, Mukesh Bhai made a statement, data is a oil. It was a half of the statement. It is a partial truth. Complete and correct data is the real oil. And there is a analogy when he said that, or he compared data with the oil. Of course, many industry experts have asserted that data has already become the world's most valuable resource like oil. In the past decade, also industry have thus coined the phrase data economy to denote the influence of the financial prominence in the big data in the today's society, or I'll say in our industry. The idea of the data is the new oil has to do with the similarities in how the two resources become valuable. Just like oil, raw data is not is not valuable and in and of itself. Rather, the value is created when it is gathered quickly, completely, and accurately, and connected to other relevant data, or I'll say the machineries which will take as an input for these data. And then this part, this statement, data is a new oil, becomes a real statement, or I'll say pure truth in our sector. Coming back to this, when properly refined, data quickly becomes a decision-making tool, providing insightful information that allows companies to react to market forces proactively and intentionally. And thus, I must say data is not only new oil, but also new oxygen now for every industry sector, not only limited with the power or I'll say energy sector. While data is oxygen, robust communication network as technology carrier to transmit the seamless data has much bigger importance. And allow my banality of the subject, our paper is based on this theme, that how the communication technology that is more important while we transmit or we talk about the data as an oxygen for the sector, any sector I'll say. I'm not limiting only to the power and the industry sector. Topics may sound quite banal in today's everyday technology changing world, but ignoring its sheer relevance and importance is only at our own peril. Reliable communication system is the backbone of efficient and trouble-free operation and management of the utility system. And in previous session, my good friend Ramanji has mentioned about the sanctity of data. So I think that with this paper, we are complementing each other and making a comprehensive solution for the sector when we talk about the data based on the robust communication infrastructure, or I'll say ecosystem in place. A typical utility today is using multiple communication systems for different operations. For example, leased bandwidth is used for experience IT systems, and utilities own fiber network or dedicated lease line is used for network automation system, while yet another communication system are used for smart metering and other utility application. There are plethora of data coming up from everywhere, and utility, or I'll say sector stakeholders, they are a custodian of the huge data. Important to have this seamless data, getting unlocking the true value of this data in the most benefit of the sectors, or I'll say the organizations, the responsibility is bestowed upon. Coming back to India has concerned or commenced or rollout of 5G network, which can unleash new economic opportunities and societal benefits, giving its potential for being a transformational force for Indian society. It cannot help the country leapfrog the traditional barrier to development as well as the advance the digital India vision. It is estimated that the cumulative economy impact of 5G of India on India can reach out $1 trillion USD by 2035. And I must appreciate it thanks to ISDF, who has been advocating for allocation of spectrum for utilities and other critical sectors to build their own private 5G network. That is very, very important, I'll say, and especially for the captive use rather than leasing from telecoms operator, which is not only costly but also may not match with the telecoms rollout plans and the utilities requirement. Government of India approved private 5G network in June 2022, which is a landmark decision. A 5G private network allows the use of 5G technologies to create a dedicated network with unified connectivity, optimized services, and a secure means of communication within specific areas. This will unified communication system which drastically improve the performance while reducing the total cost of ownership. And I must say smart hyper connected ecosystem, which is the key theme we need to focus when we talk about our I'll say progress of our sector. The smart hyper connectivity ecosystem, is the essential need of the hour for every sector, not only energy or the power sector. And establishment of smart hyper connected ecosystem is the key theme of our paper. While we think global and act local is important and has its importance to overcoming the multiple and other barriers, also calibration in setting up right ecosystem without trapped in one size fit for all approach will suffice to this. And with this, just a quick recap on the key points which we mastered, or I'll say we tried to factor in our technical paper. The importance is to taking us we all understand that every industry, every sector, every utility, they are at a different level. You cannot compare east to west or north to south. The Gujarat utilities, I'll say no offense please here if there is any utility guy. No offense, Gujarat is a quite mature discom compared to the northeast discoms. So you cannot compare maturity level, or I'll say the solution with a focus on a one size fit for all approach. There has to be customization. The importance here is to lay down the framework, or I'll say the step-wise step to reach out to that maturity stage. So just on the focus on the slide on the left side, the technical choice for the smart grid, when we talk about the bi-directional flow of information, knowledge for the and decision making, transparency, all these I'll say, or I'll take it that every sector, every utility, every stakeholder is quite aware of this. Importance is on the path. What path has to be taken up, or I'll say phase-wise approach. When we start that, the first option could be the project, then coming up to smart project, and then coming up to smart advanced project. More or less, RDSS has given us that platform where we all can say that more or less all the utilities in the sectors have reached out to a consistent level, or I say baseline has already been formed. But now it is important to look beyond this. What is we are talking about now, we have to talk about next, and what we also keep this thing in mind, that what is beyond. So coming to smart hyper connected ecosystem, this is very important considering still in many generation transmission and discoms the various applications are running in the silos. The integration of these applications are on a different platform. Though we are, like Sir said, that RAPDRP was exponent for this interoperability and scalability through SUA architecture in the one of the I'll say key point in the RAPDRP thing. But important is to leverage on this and think that what is beyond this. And that is why the concept of the smart hyper-connected ecosystem framework, that is more important, so that we can have real target in place, can move out to those targets in a seamless way, and important to give a legacy to the future generation so that they can think of that when 2020, the statement was made that data is oxygen or data is oil. It was not a misnomer. So with this, just a last recap of the our technical paper, important is what is next to us. Though as a current state, we understand where we are. Important is what is in our foresight. Yes, of course, 5G networks are expected to become widely available in the coming years, and this technology will offer significantly faster data transfer rate, lower latency and higher reliability than existing 4G network. Sir mentioned about the smart metering thing, Ramanji mentioned about smart metering thing. The success of all these projects, or I'll say the SCADA, it depends on the success of the, I'll say, robust communication system or communication ecosystem infrastructure in place. And also important, I'll say, I take this opportunity of this platform to talk about beyond next. So primary and the secondary mode of communication to be ensured for interoperability, profitability, and important is the performance audit in terms of the SLA adherence. And the cost effective combination, it can be a hybrid mode, or I'll say that like a RF and NB-IoT combination, LoRa and NB-IoT combination can be tested in pilot cases for the feasibility, so that we don't have any untouched, or I'll say gray area in terms of the communication. And the wired solution like the PLC and OFC as primary, I can understand that it is still a distant dream for the Indian context or Indian geography. But global, it has its own relevance. It has proven cases. I'll say that EY has given a platform to me to handle a PLC network engagement in the Nepal, and it has been successful there. So coming back to the different technology, it is important to how we perceive this thing, and with the fitment in our, I'll say, roadmap for next 5, 10 to 15 years. Important is to scale up the vision basis on the key foundation, and the communication setup is one of the foundation pillar of this. RF canopy supports multiple endpoints to be connected by AMI, HES, and SMOC, which REC team was also highlighting. So that is important to think on end-to-end point from the communication technology point of view for success of any IT-related project. So while we, in the RDSS, we are envisaging multiple schemes, multiple solutions of a smart grid, SCADA, IT, OT. Important is to also factor in the basic underlying foundation for the success of the solution. With this note, and in the interest of the time, I'll just take a break here and would be open for any question.
Thank you very much, Sir Inspector. My request, it has gone beyond 50 minutes. It may be that psychology is that now they listen. Once they come to the platform, they forget about the time. I'm sorry to. Anyway, it is a very important subject, sir. Actually, most of the project, in a SCADA project, automation project, failed on a single issue is communication. If you don't properly design a communication system, the whole SCADA, many examples are there throughout the world, and India is not an exception. We have many projects which fail only on this particular. So designing a communication network is paramount, and there are two things you have to keep in mind. Actually, the power system is not, the power system demands two things. One is critical functions, another non-critical function. So the critical function is time bound. Say the protection function, it is 10 milliseconds, 10 milliseconds has to deliver. So there is no question of asking anything like, economical designing like that. So you have to design only one technology is available, that's all the thing. What irrespective of what is the price, nothing. But when come to this other non-critical functions, say you take AMR, related things, even DMS, all such things, energy related things or office related things or data related, these are non-critical things. So there we have, fortunate in the last 10 years, we have variety of communication technologies available. You need to work it out which is cheapest, because communication is going to cost you a lot. Whatever, whether it is AMR, whatever you talk about it costs a lot of money. So you have to design a network, which already our friend has listed out. So you need to see that which technology is least cost for other than critical application. Yes. Thank you very much, sir. Thank you very much. Bye.
Thank you, Mr. Amit Sharma. Moving forward with our next presenter, Mr. Robbins Ento, Research Scholar at Department of Hydro and Renewable Energy, IIT Roorkee. Along with Mr. Robbins, we have Dr. Ridham Singh, Professor, Department of Hydro and Renewable Energy, IIT Roorkee. And previously, Dr. Ridham has worked at IIT Bhilani and National Institute of Construction and Management Research. So with that, I would like to hand over the stage to Mr. Robbins.
So good afternoon, everyone, and I take this opportunity to thank my professor, Dr. Ridham Singh, and Mr. Richie Pillai sir for giving me this platform. And so this particular topic is a part of a broader project where we are trying to investigate the consumer perspectives of smart grid and what are the challenges for the demand flexibility aspects. So an overview in every sense, I mean from the utility perspective and based on various case studies that is happening around the world, I will be moving this presentation. So let us see in brief. So the global electricity demand is increasing at an alarming rate at 6%, and it has reached around 24,700 terawatt hour in 2021. Okay, and the share of electricity, the most important point, in the total final energy consumption is standing at 20% by 2021. Okay. Yeah. So in a sustainable scenario, we are expecting that it will reach around 28% by 2030 and 52% by 2050. So another challenge that is coming up is with this is the load curve is continuously changing, and as against the peak, evening peak and morning peak that has changed, and now the day peak has become a reality. So there are huge challenges for the utilities, and so definitely this point out to the grid modernization. And now coming to the another thing that we what are the needs for demand flexibility. So, or the potential for demand flexibility exists because, see, there are huge millions of electric vehicles are coming into the market at the same time. There are gigawatt scale battery energy storage. So the possibilities come up. Now, according to now the thing why India requires that, according to Niti Aayog, what it says that 24% is from residential sector. So there is a scope of some flexibility if there is some behavioral management. Another thing is 28% from agriculture sector, which other countries, European countries may not be focusing, but we have such a scope of flexibility if it is properly utilized. Now, what is the possibilities of the peak demand? By 2030, it is found that according to Alliance Energy, the study says that the Bengaluru, Hyderabad, Mumbai and Kolkata, all the cities are going to double its peak demand. So it's very clear that the importance of demand flexibility, and in brief, so demand flexibility can have different definitions in utility perspective as well as in consumer perspective. So in considering the utility perspective, so we can say that it can be a portion of the portion of load that can be curtailed, okay, or it can be shifted or increased, whatever be the case. Completely modulation should be possible. Now coming to a consumer perspective, it should change their consumption pattern based on external signals. So now we can say that let us see a small report. According to IEA report in 2019, it is estimating the potential of flexible load. Each hour is 4,000 terawatt hour, and it is expecting that it will go up to 7,000 terawatt hour by 2040. So that is the potential of demand flexibility. Now let us go to few case studies from UK and European countries. So this is actually the way in which the demand flexibility has to take place. One of the case studies in UK. So we can see that the first thing is that we need to categorize the loads into adjustable loads, shifting loads, and shedding loads, as well as we need to know what are among that loads, which are those which is shiftable, which are those which are modulatable, etc. Similarly, we need to know the running characteristics as well as the frequency of use. And I mean, to make our job easy, the smart meters, the presence of smart meter will make the job easier for this categorization process. In addition to that, people may think that it is very difficult, so you have to go door to door, understand, and if there should be a dedicated mechanism with the consumers to get this data. But in addition to that, we have another process in which we can use the help of ANN. Now, after doing that, we have to plot this load curves. Okay, in the load curve, we can see that here there are certain things which is in the load. The dark blue shows the continuous torque induction motors. The other one, the just above light blue, which shows the quarterly torque induction motors, and towards the end, the lighting, the yellow shows the lighting curves. So from this load curve, we need to understand which is the trustable load for the utility for the shedding process or modulation of this particular load. On the right hand side, we can see a very important thing. However we engage the consumers, the most important thing to maintain the load curve is that we need to have an aggregation of load. So the first row, we can see that is a load curve for 100 houses. The second row is for 200 houses, and the last row is for 1000 houses. So we can see that load curve is stable when there are more number of houses. Now, as I said, see, going to door and engaging the consumers is very difficult. So we can use the help of ANN, where we need to understand only 5% of household. We need to investigate thoroughly the load of 5% of household, and we can predict for how many, say, whatever that is required. So if you are able to get the exact data for 5% using ANN, you can predict the remaining load in a successful manner, so that may not be a burden for the utility. So I'm not explaining the block diagram of that. So this is another case study which is done in Norway. So we can see that the dark line shows the decrease in the when the external trigger signals were given from the utility, the consumers are able to load curve goes down. That means consumers are cooperating. But again, the same thing that is to be noted, that the red line, the same consumers may not cooperate in the weekends, because so that is another challenge that utility has to take up. So this is another case in Belgium, where they have investigated among 430 houses and 186 appliances, in which these are some of the appliances like dishwashers, washing machines, tumble dryer, etc. So the green points that they are ready for. The green towers are they are ready for the cooperation, and the flexibility is done. And the red shows that due to some reasons, maybe the problem because of the equipment, or they are, even if the house is smart home, they are not willing. So proper consumer engagement has to be there to take up the process. Now let us see another case study on Europe, and where the study has been done on almost all the European countries with 22 potential lots in the houses, and they could find that there is a theoretical DR potential was estimated, and the minimum load direction capacity was 61 gigawatt, and the maximum was 68 gigawatt, which is very huge. And so that's the potential of demand flexibility in Europe. Now let us see, this is a critical point. See, in 2030, what are the potential equipments which we can rely upon? See, the commercial and residential energy storage system by 2020 have the potential of 3.6 gigawatt, and we are expecting that in a net zero scenario 2030 it is 510 gigawatt is the potential. Now coming up in future, by 2030 we can see that smart thermostat of 235.5 million, which is under scope, home energy management system 32.7 million, residential home appliances of 2.6 million. So these all things, if properly utilized, can add to the potential. So let me come to the last two slides. So so it is clear that from the various case studies that there are a number of appliances. Basically, we can rely upon storage heaters, washing machines, tumble dryers, and dishwashers. That is Europe. In our case, in India, it will be slightly different. We need to investigate that. And now, according to IEA, by 2030, the demand flexibility potential that is available from the buildings is 250 gigawatt. Okay, this particular target can be achieved by just 10% of them. If it is coming up, we can achieve this particular target. Now we can see the total installed capacity of renewables in India has already surpassed 100 gigawatt, and the ministry has revised the target to nearly 500 gigawatt by 2050. So we do have this potential, and there are a lot more provision for rooftop. So more rooftop coming means again by domestic consumers more potential. Now this is my last slide, and let me remain with this. When compared to other European countries, we have something that is different, which was done by a study, which was proved from a study by NREL in Bangalore. So that in that study it is proved that in addition to other cases, we need to focus on agriculture sector, which is having 28% of the consumption in India. And what is the beauty? The beauty is that agriculture consumers can offer more flexibility in a day without much sacrifice in their agriculture work. Then a recovery time can be up to 24 hours. That means a more relaxed recovery time than any other things. And each DR event can last up to 3 to 7 hours as against small appliances. So at the end of the day, it is from the study it is found that the most successful one is load shifting, and I would like to say that there needs to be a very vast and extensive research to prove the capacity of demand flexibility in India. Once again, thank you so much.
Thank you, friend. Thank you very much.
That's the end of our session, sir, for the themes that we covered.
So nice.
So, any final remarks, sir?
That's, yeah, it's good. So anyway, the smart grid is, though in many countries, various forms of maturity has reached because of, they continuously working with many organizations, standard bodies, all such things. So many countries have reached a certain amount of maturity in each building block, which I mentioned, from home automation to you can electrical storage and all such things. Friends, very important thing is that we lose. So friends, what is lagging? I work with the utilities all my time. Very important thing is the standards. The standards is missing. We spent about almost 12 years in standardizing in a metering protocol, which is already available as from the form of IEC. So this kind of things, it really retard, or it may not, it may not integrate with the other systems. So about 250 plus standards are there for proper integration of various building blocks of smart grid system, starting from home automation to your electric vehicle. So understanding the standard is in a paramount. Otherwise, what happened? Previously, we are talking about only in a meter. Then we went to AMR, then AMI. Then we stopped with only collecting the data. We are not taking the data to distribution management. There are systems already evolved, like 61968, 61970 in a common information model. Once you take the data, it should be made available to various functions. So that is lagging. So I request the friends who are sitting here to just to see not only that somebody is working on smart meter, they should not stop with only a metering in a standards, metering protocol or communication protocol, or maximum at the end of your meter data center. Beyond that, you need to connect it with your distribution management systems, all such things. So it is very, very useful. So that we should keep in mind. There are international standards. International standards are available. Already it has come to that level. So we should make leverage of these standards available, especially IEC. IEC has done a great work, which we are adopting, with a small gap and release as Indian standard. But in spite of it, you can always access IEC, and there are now, it is called smart energy. Previously, some about, some 30-40 technical committees are there to cover entire scope of your smart grid. Now it's under available and smart energy under one itself. So you will have plenty of information available there. That's it. Keep in mind.
So adopting these standards is a paramount importance because otherwise we cannot export these products.
And not only that, sir, actually for smart grid, basic function is that the information need to flow seamlessly. We have not shown you that the building blocks. You start with generation, transmission, distribution, then again integration, then your dispatch. So many functions are there. So information need to flow seamlessly. So it is possible only when you have standardized things like that. Otherwise, you will put what you call in between. You will put connector. So the connector will be weak. You know, one standard one side, another is another standard. So you will put protocol converter. Then you are creating, kind of interruption in between. So failures, then the time consuming, all such things. Then you need to have many the inventory and all such things. So literally we should have, as a distribution engineer, I would like to have only one standard, but it is not possible. But at least there are industry-driven standards. If we go to home automation, the people who are all working on power system may not work on the home automation because they keep it as a secret, closely secret, guarded secret. They will not allow you to come inside. And same thing with power system operators, power system manufacturers, they may not allow these guys to come here. So there are commercial things, but all said and done, we need to move with standardized things like that, no proprietary.
Yeah, another challenge is to deal with the legacy systems, wherein you would not like to change the system.
That you have to do that, sir. You have to. Otherwise, you may not go further. You have to take it. There is a very, very expensive, very costly decision you have to take. Otherwise, you will end up with old thing. It will be a very costly proposition.
So, thank you everyone for this session. Now I would request Mr. N. Murugesan to kindly felicitate our participants for this session with a memento of thanks, and we'll have a group photograph with everyone. Thank you so much, sir.